Hello, everyone. I'm Jay Paloma. I'm from Manila, Philippines, and I'm currently based here in Singapore. I'm an IT person by profession and a musician and sound engineer by passion. For my assignment, I will explain the signal flow in my home studio. But before that, let me tell you a little bit about myself. As a hobby, I record my own covers and original music, as well as create how-to videos and on technologies I'm working on. For this reason, my home studio should be able to cover both spoken voice and music recordings. Here is an overview of a typical home studio setup. You see there the important components. First, we have our sound source, say a singer's voice, which is sound energy picked up by the microphone. Then the microphone converts the sound waves into electrical signals, or what we call low-level audio signals, and is sent to our audio interface. This audio interface then does two important things. The microphone preamp amplifies the low-level audio signals into line-level signals. Then the analog to digital converter transforms our audio signal into digital form, which is then sent to our digital audio workstation, or DAW. In our DAW, we now create our music by adding more tracks, adding effects, and so on. Of course, we need to hear what has been recorded in our DAW, so the audio that we play back from our DAW is sent back to the audio interface as digital signals. In our audio interface, the digital signal is converted back to its analog form and is sent to our monitors as electrical signals. Our monitors then convert these electrical signals back to sound energy, which we hear. Let us now take a look at each component in more detail. The microphone is what's called an input transducer. In the case of the microphone, it converts sound energy, which is actually air pressure variations, into electrical signals. The microphone in our example is an Audio-Technica AT2020, which is a cardioid condenser microphone, connected to the mixer via XLR cable. Now, a condenser microphone requires an external power source called phantom power, so we need to make sure that a source of phantom power is available. The audio interface we are using has one. The microphone is connected to the audio device via an XLR cable, or a balanced cable. Our audio interface is a Yamaha MW12CX mixing console. It's basically a mixer with a USB interface. Prior to recording, we need to set up the microphone so that it is in proper line level. We do this via the gain knob and the peak LED. The mixer also functions as an analog to digital converter. But to make use of that digital information, we need to connect our audio device to our computer. For this Yamaha mixer, we connect via USB since it has no FireWire capability. The digital audio workstation we use is Cubase 7. This is the software where we process our audio. The studio monitors we use is the Tapco S5. We need to make sure that we use studio monitors and not commercial-grade home speaker systems. During a voice recording, we also need to see to it that we use an enclosed headphone so that our speaker or vocalist can monitor his or her voice, but the enclosed configuration prevents the sound of the from the headphones from being picked up by the nearby microphone. I really enjoyed this first lesson. It gave me an opportunity to review my own equipment and how it can be improved. Quite frankly, it is the mixer that bore the brunt of my equipment review. As of now, though, it still delivers what I need. I also like the fact that the assignment involves creating teaching material. I share the same sentiment as Loudon. that the capability to teach a certain topic means one fully understands that topic. As for the reviewers, I will appreciate truthful and generous feedback during the review process. Thank you very much for viewing this video.